All right, guys, I'm about to go over the review for this test. So I posted the key, but here I'm posting the video going over the key as well that I'm about to do. Let me just make sure this works. All right, so for number one, here we have to identify that we have to use product rule. So that's just f prime of x. Sorry, this didn't work too well. F g prime plus g f prime. It's a minus. And that's it. So here we just have to know that we have to use product rule. We didn't have to use chain rule at all. So be careful. Number two, same thing. Here, we're multiplying. There's not something inside of anything else, so we have to use product rule. So our derivative is f g prime. Remember, the derivative of tangent is secant squared plus g f prime. There you have it. All right. Remember, and you guys can pause, go back anytime you need if I'm going too quick. Here, nothing inside of anything else. We just have quotient rule. So that is here. G f prime minus f g prime all over g squared. You got it. Write the equation of the tangent line. So as soon as you see equation of the tangent line, that's, our point slope. All right, so we need our y, our x, and our m. They give us our x, so to get our y, we just plug it back into the original. So that'll be negative 2 times 5, which is negative 10. Now all we're missing is my m, which is my derivative. So, or it means my slope, and I get that from the derivative. So I take the derivative. Which rule do I use? Oh, it's product rule. I'm multiplying 2. So let's get our derivative by doing product rule. F g prime plus g f prime. Now plug in the x value in this case, which is 1. So that'll be negative 2 plus, what's that? So let me just title it. Yeah, that looks confusing. Plug in 1, that's 5, 2, so that's 10. So negative 2 plus 10 is 8. So now I can get my final answer. Y plus 10 equals 8, x minus 1. All right. Go on to the second one now. So again, we're doing point slope. So we need our y and our m. Plug in 0 into the original, that's negative 3 over 2. My m is my slope, which I can get from my derivative here. To get the derivative of this, that's quotient rule. So, sorry, that's just g f prime minus f g prime all over g squared. All right, now to plug in 0 into here, to my derivative, that'll be 2 minus -3, end up being, let me make sure, g. And sorry, that ends up being 2 plus 3, which is 5 over 4. So here I go, y plus 3 halves equals 5/4 x minus 0. Do you really need that minus 0? No, but I'm putting it there just so you can see. All right, this next problem, now we get to chain rule because we have an inside. So we take the derivative of the inside, which is negative sine 3x times 3, because 3x is my inside. Here, the next one, I have an inside. So let me do the derivative of the outside, which is cosine. Leave the inside the same. Then multiply it by the derivative of the inside, which is 10x. So I know a lot of you guys have been wondering, how do I know when to keep going? Like, do I need to multiply by 10 now? So what I do is, you can ask yourself, do you have an inside? Every time you do the derivative, like we did the derivative right here, we had an inside. So I took the derivative of that. All right, here, now do I have an inside? No, I just have 10x. There's nothing inside of anything. So I'm done. This next one right here is cosecant. So the derivative of cosecant is negative cosecant cotangent. So this derivative has two parts because that's just the derivative of cosecant. So here we have to put the inside, the original inside, which is this, into both of them. So that's to the 5th power. All right, now we multiply it by the derivative of that inside, 35x to the 4th. So I get the question, well, since there's two of them, do I need to put both? Do I need to put this twice? No, because this just counts for the one derivative of the outside. The inside was just both of them. And then after that's finished, you just multiply by the derivative of the inside. In this case, it was in both of them, but we just need to put it once. Number 9. It's chain rule because we have an inside. So we take the derivative, secant squared. That's the outside derivative. Leave the inside the same. Then we multiply by the derivative of the inside, which is cosine x. Do we have an inside now left? We had an inside over here, which was here. Now for this part, do we have an inside? We just have x. So we're good. So we're good to go. If you really wanted to, you could take the derivative of this inside part, which is just 1, but you don't need to multiply anything by 1. But other than that, there's no inside. Number 10. So here, they put the chain rule in this form where you have an inside. So whenever it's like this, let's take the derivative of the outside, which is f. So to take the derivative of f, we just put f prime. Leave the inside the same. And then we multiply by the derivative of the inside, which we can just say is g prime. So there's our derivative. Now they want us to actually plug in 3 into x. So we look at this. We look at the inside part first. What's g of 3? That's what this is, 4. So this g of 3 just became 4 inside now. This 4 is inside of this. G prime of 3, that's over here, that would be -5. So this part became 4. This part became 5, or negative 5. And now we can figure this out. That's what's f prime of 4. Oh, they gave you over here. So 8. This is just still negative 5, which equals negative 40. All right, here we have product rule because we're multiplying, and then we also have chain rule, but we don't need to get to this until we do the derivative of this part. So remember, this is just regular product rule, f g prime. Now when I take the derivative of this, I need chain rule. Do I have an inside here? Yeah, I still have an inside. 2x, sorry, it should just be 2. The derivative inside is just 2. Plus, so that was my g prime. So this right here is f. All of this right here was g prime plus g. Now is 2x minus 4, including that third power. That's part of my g, times the derivative of f is 2x. And there you have it. So that was product rule, and we use chain rule within the product rule right here, right, for that g prime part. Now we get to quotient rule. So let me just rewrite this as x squared plus 2 to the 1/3 power. That's the same thing. That's just easier to do it. Set that to 3. All right, so now when we do the derivative, that's quotient rule. So that's g, including the 1/3, that's part of my g, f prime minus f g prime. Now I have to do chain rule at this part right here because I have an inside. So that's 1/3 x squared plus 2. That was my inside that I'm leaving the same. Minus 1 times the derivative of my inside, which is 2x. So this is my g, f prime minus f, g prime. All of this is my g prime. That's all over g squared. So I'm not even cleaning it up, but you can if you wanted to. You can make this 2/3, or you can put it in the square or the cube root form. Go from there. All right. Number 13. Here we have chain rule, but then we have the inside part, that's quotient rule. But let's do the outside part first. That's 2 to the 1 power. And we leave the inside the exact same. Now we have to multiply by the derivative of the inside, which is quotient rule. G f prime minus f g prime all over g squared. And that does everything. That's chain rule, and then we have product rule or quotient rule. All right, here I know this was kind of tight. Here, let me see if I can make this bigger to get room to do all these. All right, here, let's write this as cosine x squared, all of that to the second power. That's what that means. So this is easier to see that it's chain rule, but we use double chain rule. So 2 all of that to the 1 power. So we leave that the same. Now we move on to this inside part. Take the derivative of that, which is negative sine x squared. Now, do we have an inside to this? Yeah, we do. That's how we know we have to keep going. 2x. Do we have an inside to this anymore? No. So if you put times 2 here, it would be wrong. You have to see that there's no inside to here. That's it. Over. All right, here's another one. So here, let me rewrite this as secant 5x all to the third power. All right, so the derivative of this, we'd have to do quotient rule, which is g f prime, so that's chain rule, 3, leave the inside, the exact same, times the derivative of this inside. You can see there's an inside. Secant, the derivative of secant is secant tangent, leave the 5x. Is there an inside to this part? Yeah, inside both of them, there's a 5x. So I multiply it by 5x. So all that was just g f prime. I know that was a long part. G right here. All of this was f prime because that was my double chain rule right there. Minus f, my original f, times g prime, just 4, all over g squared. So this was my f, and this was my g prime. And this is my g squared down here. So again, if you're having trouble trying to decide to do double chain rule, how far should you go? Ask yourself, once you do each part, is there still an inside? Here, I took the derivative of the outside. I had an inside, secant 5x. Took the derivative of secant x tangent x, but it's a 5x inside. So I still have an inside. So then I take the derivative of this inside, which should, oh, yeah, that was my mistake. It should just be 5, actually. Because the derivative of 5x is just 5. That's where I went wrong. Yeah, there it is. All right. Number 16. I know these are long. We're almost done. 16. Sorry, I'm just trying to scroll down to get the most space. All right. So here we have product rule. The only thing is I'm going to write this as cosine 5x all to the 1/2 power, because that means square root. So we have product rule, f g prime, which would be 1/2, leave the inside the same. Oh, look, another inside. So the negative 1/2 times the inside derivative, negative sine 5x. Oh, I still have an inside. Times the derivative inside, which is 5. So that was my whole g prime. F g prime plus g. You can put the square root or the 1/2 power, whatever you prefer, times f prime. That was my product rule. Using double chain rule inside of it. And this last one, we have chain rule inside of chain rule. So if you look, we have an inside. We're not multiplying or anything yet. All we're doing is we have cosine of all of this. So let's take the derivative outside. Negative sine. Leave that whole inside the same. Now ask ourselves, do we have an inside? Yeah, we still have an inside right here. So we're going to take the derivative of that inside, which is cosine 9x. Do I still have an inside? Yeah, I still have this inside right here. So I have to take the derivative of that, which is just 9. And that will be it.